which is on mixtures and averages. As you can see, I have these two drinks out here, a cola and an orange. And if the objective of having these two drinks was to just get a new drink which would have equal quantity of cola and equal quantity of orange, then the simplest thing to do would be take a glass and take half of cola and half of orange, and that would be your new drink. But now suppose you want to achieve the same objective from a different start point. Let's assume I have this glass where I have cola and orange mixed in the ratio 2:3. I put 2 parts of cola and 3 parts of orange, versus I have another glass where I have 3 parts of cola and only 1 part of orange. So what I have done is I have these two glasses, cola to orange in the ratio 2:3. This glass where I have cola to orange in the ratio 3:1. And now the objective is the same as earlier. I need to take some quantity of this and some quantity of this, mix them together into this bowl so that the resultant drink that I have still has equal quantity of cola and orange. How do we manage this? The solution to this depends on our concepts of averages and alligations, which are also called as mixtures. So let's go through the concepts and then we come back to this question and get the answer to this question. We will start by understanding the concept of average, or what is also referred to as mean. So when we talk about simple average, or if we talk about what is very commonly known as arithmetic mean, then what is arithmetic mean? So if you're given a set of values and if you want to find the arithmetic mean for the set of values, then it would be calculated as sum of all values divided by the number of values. So if we have values, let's take an example. If we have values like 23, 25, 29, 37 and 40. We've taken 5 values here. So the arithmetic mean for this set of 5 values would actually be sum of all the values. We would add up these and divide by 5. That would be the value for arithmetic mean. There's another way of calculating the value of arithmetic mean, and that is known as the method of assumed mean. Now what this method actually does is we consider any value between 23 and 40 as the value of the arithmetic mean. We are assuming a value as the mean. So let's take an example where we say the value of the assumed mean is 30. Suppose we say assumed mean is 30. Now what we would do is we would find the difference of each value with respect to the assumed mean value. So 23 with respect to 30 would be -7. 25 with respect to 30 would be -5. 29 with respect to 30 would be -1, +7 and +10. So we found the difference of each value with respect to the assumed mean, and we will now find the mean of these differences, which means we add up all these and divide by 5. So -7 cancels off with +7. This gives me a -6 plus 10. So +4 upon 5, which would be a 0.8 plus 0.8. What this tells us now is that the actual mean will be 0.8 more than the assumed mean, and hence the arithmetic mean of this set of values would be 30.8. If this final answer was a negative value, it simply means that the actual mean should be lesser than the assumed mean, and we calculate accordingly. So this is the method of assumed mean, where we assume a certain number within this range to be the mean and find the mean of the differences of all these individual numbers with respect to the assumed mean, and then we either add or subtract from the assumed mean value depending on whether we get a plus sign or a minus sign. Having done the basic funda of arithmetic mean in terms of a formula and how to calculate arithmetic mean using the concept of assumed mean, we will also always notice that the value of the arithmetic mean would always lie between the smallest and the largest of the original values. By between, we don't necessarily mean the midpoint, but we will always notice that arithmetic mean is greater than the smallest value and lesser than the largest value out of a given set of values. We've already studied what is average. We now move on to a different concept called as weighted average. Now, first of all, when is this concept of weighted average even applicable? There are a few examples where the example talks about finding the average of an average. Let's try and understand this using an example. Suppose I say 3 kgs of sugar costs 10 rupees per kg. The moment I say 10 rupees per kg, it means the average price of sugar of this variety is 10 rupees. And I have 2 kgs of sugar costing 25 rupees per kg. So this is the average price of this variety of sugar. Now, if I mix them together, then what is the average price of the mixture? The moment I want to find the average price of the mixture, it is in a way finding the average of these two averages, but I can't simply add the two and divide by 2 because the value or the weight rather for this variety or this price is different as compared to the weight for this price. And hence we use this concept of weighted average, where a general formula would be W1x1 plus W2x2 and so on divided by W1 plus W2 and so on. W1, W2 indicate the weights assigned to the individual averages, which are x1, x2 and so on. So if I use this formula in this example, we say that 3 kgs of sugar costing 10 rupees per kg would mean a total value of 30 rupees. 2 kgs of sugar costing 25 rupees per kg would mean total value of 50 rupees, and 30 plus 50 would make a total mixture value of 80 rupees, and then I divide by the total quantity, which is 5, and hence the average here would be 16. So essentially what we do is we convert each average into its total. That is what we've achieved here. Second average into the total. We add the two totals to find the overall total and then divide by the total quantity. That is how we would find the weighted average in this question. Now another way of finding the weighted average would be what is known as the method of lever. Now what do we mean by the method of lever? Suppose we have some kind of a lever here and we say 3 kg is 10 rupee per kg, 2 kgs is 25 rupees per kg. Now if I want to find the average, it would simply mean I need to balance out this lever, and I want to find out at what value would this lever be balanced. Now when I see the individual values of 10 and 25, and if the weights are 3 and 2, then the balancing would be done in the reverse ratio, which would mean 2 here and 3 here. If I check the difference, which is 15 between these two values, I need to divide this difference of 15 in the ratio 2:3, and if I divide it in this ratio 2:3, then these two parts would imply 6 and these three parts would imply 9, and hence the way I would balance this lever is if I add 6 to 10 or if I subtract 9 from 25, which would give me the same value 16. So a way of calculating the weighted average is also by trying to balance out this lever. The only point that we need to remember, when you want to balance out these two values, it should be done in the reverse ratio. Divide the difference in that ratio and find that point at which the balancing out happens. Having seen the basics of averages, we will now move on to an application specifically of weighted averages, which is called as alligations. Now alligations in very simple terms actually refers to a mixture where two different varieties are mixed and a certain average gets created for the mixture. So let's take an example, a similar example that we've seen earlier. If we were to mix two different varieties of sugar, suppose one variety of sugar costs 10 rupees per kg and a second variety costs 25 rupees per kg, and they are mixed in a certain manner or in a certain ratio such that the average works out to 16 rupees per kg. Now in the previous example we actually worked out this average. This example of alligations is where the average of the mixture is also given, and we need to find out in what ratio should the two varieties be mixed so that the whole condition gets satisfied. So we've looked at one variety of sugar which costs 10 rupees per kg, another variety of sugar which costs 25 rupees per kg, and the average is 16 rupees per kg. The question is, in what ratio should these two be mixed? Now the way we would solve this is by creating a structure of this type and then subtracting along these lines. Now one important point that we need to understand, if this is the average, then it has to lie between these two values. And if it lies between these two values, and if we were to subtract so as to get a positive difference, then one subtraction would be average minus the smaller value, which would give me a 6, and the other subtraction would be larger value minus the average, which would give me a 9. What do these two numbers 9 and 6 indicate? It simply means that in the final mixture, you should have 9 parts of the 10 rupee variety corresponding to the 6 parts of the 25 rupee variety. Hence, the ratio in which they should be mixed is nothing but 9:6, which can be simplified to 3:2. So what this now tells us, if we take 3 parts of the 10 rupee variety of sugar with 2 parts of the 25 rupees variety of sugar, and if we mix them, then the average price of the mixture would work out to 16 rupees per kg. So this is an example where instead of the ratios being given, we actually worked out the ratio in which they should be mixed subject to these 3 values. Now though we have taken a case of a mixture, every time we use this concept of alligation, the problem may not really involve a mixture, or it may involve a mixture of a different type. For example, if these 3 were to reflect the percentage return on an investment made. So suppose I say I have an investment or a certain amount of money invested such that it gives me a 10% return, and a certain other amount which is invested such that it gives me a 25% return, and the average of these two together is 16%, then what would be the ratio of the investments? And hence, using the same concept of alligation, we would find out that if we want a 16% return on an average through these two, then the ratio of investment should be 3:2. Further application would be if you are told that this investment of 25% return is actually 1 lakh rupees, then we would say these 2 parts correspond to 1 lakh, and hence these 3 parts need to correspond to 1.5 lakh. So the question could also be, how much money should be invested at 10% return along with 1 lakh invested at 25% return so as to get an overall return of 16%. Now this problem actually may not be a real mixtures kind of a problem, but can be solved using the same concept of alligations. In fact, alligations is a concept so useful that wherever this concept can be used, it is normally the fastest way of solving that question. Hence, if you master this concept, you can actually save a lot of time when you're solving problems. So now if we get back to our earlier example of the drink that we wanted to create using cola and orange. We had these 2 glasses. In this glass we had cola and orange in the ratio 2:3. In this glass we had cola and orange in the ratio 3:1. And we wanted to make some quantity of this and some of this into this container so that we would get equal quantity of cola and orange, and the question is, in what ratio should they be mixed together? So let's see how to solve this question using the concept of alligations. So if I take only cola in the first glass, then since the ratio was 2:3, we would know that 2/5 of this first glass had cola. In the second glass, the ratio was 3:1, and hence we would know that 3/4 of this second glass was cola, and the objective in the mixture is to have equal cola and orange, and hence we know that in the mixture we want half of cola. So now if we use alligation and if we subtract, then we know that this value is larger as compared to this value, and when we subtract half from 3.4, we would get 1/4. When we look at this subtraction, and if we want to see the difference between these two, we would know that 2/5 is less than 1/2, and hence if we want to subtract, we can convert these to the same denominator, which would be 10. This is 4/10, this is 5/10, and the difference would be 1/10, and hence now if we look at the ratio, it would be 1/4 divided by 1/10, which is nothing but 5/2. So the answer to this question is, if we were to mix these two, then they should be mixed in the ratio 5:2, which means 5 parts of the first glass and 2 parts of the second glass. There's another way of solving this question by converting these values into percentages. So 2/5 would be nothing but 40%, 3/4 would be nothing but 75%, half would be nothing but 50%, and hence if we now solve it using these percentage values, we get 25:10, which is nothing but 5:2, the same answer. So if we understand this application, then what we can also understand is that if we convert this situation into a bar kind of a situation, and if the bartender is given some target of how much alcohol is required in the final drink, then the bartender can actually decide how much of alcohol to mix with how much of something else to get a particular kind of a cocktail, and maybe hence this topic can actually be included in the bartender's training program.